So as you can see, there's really a lot of rooftops, DOAS units out there in the market today. And that's why we need to make sure that they're running efficiently and running with green refrigerants. So there's a lot of things that have been put on the manufacturers of rooftop and DOAS units as of late. And that's kind of how we got to where we are. So as I mentioned already, right, this energy efficiency is a big issue that they need to design to. We're talking 15% increase over the existing designs. They have a refrigerant change that they need to manage. They have to design for now an A2L, a mildly flammable refrigerant. So again, not such a simple change for them to make, right? They have indoor air quality. That's really becoming an issue right now, right? 5 years ago, if we just had cold air coming out of the vents, we were way happy, right? We weren't sitting outside in the hot sun. Great. Today, that's not the case, right? I mean, given the pandemic that we've just gone through, people expect not only just cold air, right? We want the right temperature air. We also want good humidity control so we're comfortable. And most importantly, right, we want to know that it's clean air, filtered air, safe air that's coming in, fresh air coming into our buildings. So we've got to take all these things into account with that next generation rooftop and DOAS units. And then, of course, some of the things that, installers and end users like, right, is connectivity or Internet of Things on the units. Having one unit run efficiently is of course important, but then when you talk a big strip mall or shopping center where you've got lots of these rooftop and DOAS units, of course you want them all talking to each other, right? Having one unit run all the time while the unit next to it is shut down isn't the most maybe efficient way to use all those units. So you want them talking to each other. You want to make sure that you're really optimizing your whole building and not just optimizing one unit here or there. And of course, with IoT, we have preventative maintenance, right? Maybe we know when a belt is getting ready to fail or when a compressor has stopped working within its operating range, and we can do some maintenance there. That's becoming more and more important as well. And then last, we see really a big continuous push on resources. And I think there's two different ways we can look at resources. One are the human resources, because again, redesigning for a new refrigerant, redesigning for a higher efficiency, that's a lot of lab work. That's a lot of engineering time that's going into getting these units to be efficient and to be safe. And that's a lot of work that all the manufacturers have to do. Secondly, from a resource standpoint, right, it's the raw materials themselves. We've all seen, especially as of late, copper going up, steel going up, aluminum going up. We see all these prices going up, so we want to obviously minimize the materials going into the unit and not just make a unit that has a heat exchanger 50% bigger than it is today, which maybe will help you get the efficiency done, but certainly not a good use of raw materials. And if we look back, of course, on climate change, right, we don't want to be taking all these raw materials out of the ground, throwing them away, right? We want to make sure that we're minimizing the impact we have on the environment with the materials that we're taking out, right? And then finally, our last point that, especially here in North America, is I think going to be something maybe a little new, and that's a move away from burning fossil fuels, natural gas and heating oil, and going to electricity for heating. So in the US, rooftops, typically when they have heating, it's going to be a gas-fired heater, right? So, or maybe hot water running through there. So it's going to be some type of fossil fuel that's going to give us heating on the rooftop units. I think roughly today about 10% of rooftops today are reversible heat pump units. Going forward, right, we want clean energy. We don't want to be burning these fossil fuels. So we want to work with electricity, and that really means heavy investment in reversible systems. So a heat pump, when we talk about a rooftop, is really just a unit running in reverse, where rather than blowing all the hot air out and blowing the cold air into the building, we reverse that cycle and blow the hot air into the building and pull the cold air out. And so that's something we're going to see more and more of going forward. And that's really not just for rooftops, also on the residential side. And that's something we haven't done a lot of in the US. I think heat pumps have maybe got a bad name in the US because we tried them back in the 70s. Some of us were around in the 70s. And what we thought it was too cold of air. It didn't work when it was low temperatures. There were a lot of complaints on the heat pump. This technology has really come leaps and bounds since those first heat pumps were introduced. Today they work in low ambience. Today you get warm air. So it really is a good alternative and not a sacrifice to move to a heat pump. So look for those also coming very soon when we talk rooftops and DOAS units.